So here we have section 5.1 system of linear equation and inequalities in two variables. Now we know what is the linear equation. Now what is the linear equation? What kind of equation are linear equation? Does anyone know the general form of the linear equation, how it looks like? How do we represent the linear equation?
X has an exponent of 1.
So we have the variable with exponent 1, okay? And so here, let's take the linear equation. And what kind of graph do we get when we plot a linear equation? So you have a linear equation, and if we plot a graph for the linear equation, what kind of graph do we get? Is a straight line, right? So if we have a linear equation, then the graph of every linear equation is a straight line, okay? Or if you have a straight line, then they are the linear equation. Now here we have the system of linear equation. So system means if we have a two or more than two linear equation, then that make a system, okay? So we have one linear equation, and if we plot a graph for one linear equation, we get a straight line. Now we collect. Now if we have a equation, okay, we have a linear equation and they are more than two. So you have a two linear equation at a time. Or if you have like three linear equation at a time, that make a system of linear equation, okay? So system means you have at least two linear equation or more than two linear equation at the same time. So that make a system here. And similarly, we have seen the linear inequality, and if we have a two or more than two linear inequality, that make a system of linear inequalities, okay? Now in this section, we will try to solve system of linear equation. We will try to solve system of linear inequalities. And solving means we are trying to find the value of variable, okay? Our equation has a variable, okay? And we need to find the correct value for that variable. Now here we have an example here. So let's see here examples. So we have this example. So we have the linear equation, negative 3x plus 2y equals to negative 5. This is one linear equation. And we have 5x plus 4y equals to 12. So we have two linear equation, okay? And we have to solve this linear equation. So solving means we need to find, okay, we need to find the correct value for this variable. So our variables are x, y. So we have two variables, and every these variables has a degree 1, okay, and it's a linear. So linear means the variable has a degree 1. So it must has a exponent 1. That makes a linear. Now here we need to find for what x and y value these equations are true. So we have two linear equation. Now for what x and y value these equations are true. That's what we are trying to find here. So we need to find a value for x and y, okay, that make these two equations true, okay? Now if we graph, now is there something different when we graph these two, okay? So if we graph the linear equation, we get a straight line, okay? And when we graph this linear equation, we find a point where the two lines intersect at a point, okay? So it's not every time. If we are solving, okay, if the linear system of linear equation has a solution, then those two lines intersect at a point, and that in the point where the two lines intersect is the solution, okay? That's the graphical method that we will do later on. But at first we will use elimination method to solve this system of linear equation, okay? And in the elimination method, we have to eliminate one variable, okay? So let's take example here, example A. So we have the two variable x and y, okay? So we have y and x. We have these two variables. Now by adding or subtracting these two equations, okay? So let me call this is our equation 1 and this is our equation 2. So we have two different linear equations. Now we have to eliminate at least one variable. You can eliminate x or you can eliminate y by adding or subtracting equation 1 and 2. Okay, that's the elimination process. So you eliminate one variable. It doesn't matter what variable you eliminate. You can eliminate x or you can eliminate y. Okay, and how do we eliminate? By adding or subtracting equation 1 and 2. Now, if we add or subtract these two equations, is there any way we could eliminate? So what variables can we eliminate here? Okay, before this one, let's do simpler examples. Okay, so it will be clear for you. So for example, let me add one more example. Let's say I have an equation x plus y equals to 4, and I have 2x minus y equals to 2. So I have these two equations. So this is a system of linear equation. Okay, now we have these two equations. Now we have to use elimination. Okay, we have to eliminate x or y, doesn't matter. Now, is there any way we could eliminate one variable by adding or subtracting these two equations? Okay, what do we have to do? Do we have to add or subtract these two equations? Now, let's see, if we add or subtract, so we have the two options. You can add or you can subtract. Now, if we add these two equations, let's see what happens. So you are adding. Okay, when you add, the sign of the terms, it does not change. Okay, now let's add. So x plus 2x, we have 3x. Okay, and y plus minus y, that is 0, right? It cancel, equals 4 plus 2, that is 6. Now we solve this equation by dividing both sides by 3. So we divide by 3. So we get x equals to 2. So our x is equals to 2 here. What we did? We eliminated y variable by adding equation 1 and 2. Sometime you might need to subtract. Okay, so you are allowed to add or you are allowed to subtract. Okay, to equation to eliminate any one variables. That's the first step. You eliminate one variable. If you eliminate one variable, you get the solution, you get the value for the other variable. Okay, now here we know x is equals to 2, but our target is finding the value for x and y. Now how do we find y here?
Plug it back into the equation.
Right, so now do we have to have a specific equation, or we can choose any equation to substitute this x equals to 2? It doesn't matter. You can substitute x equals to 2 in 1 or 2. It doesn't matter. You end up getting the same number. So let's substitute this x equals to 2 in equation 1. And you can substitute any. You can substitute in equation 2. It doesn't matter. So we substitute this x equals to 2 in equation 1. So we have our equation 1, x plus y equals to 4. Our x is 2 plus y equals to 4. Now we solve this equation for y. For that we subtract 2 on both sides. Okay, so this 2 cancel, and our y is 4 minus 2, that is 2. So our y is 2, x is 2. So when x is equals to 2 and y is equals to 2, both of these equations are true. Okay, we can check this. So if you substitute 2 for x, okay, and 2 for y, we get 4. 2 plus 2 is 4. Okay, similarly, this x and y should satisfy our equation second. So we have 2 times our x is 2, okay, minus our y is 2 equals to 2 times 2 is 4, 4 minus 2 is 2, and which is our right side. So we have the values for x and y, which is true for both of this equation. Okay, and these two are a solution, and we write the solution in an order pair. Now your x is the x coordinate and y value is the y coordinate. So your solution for this system of linear equation is a order pair. So when we have a system of linear equation, when we have a system of two linear equation, we get a order pair as our solution. Okay, your x value is the x coordinate, y value is the y coordinate. Okay, now in graph, if we graph these two equations, what does this solution mean is that when we graph these two linear equation, okay, when we graph this equation 1 and equation 2, this solution represents that. Okay, so we have this line. Okay, let's draw a graph here. Now, okay, so we have this 2 and 2 point. So it means these are not the correct graph, but here the solution is the point. Okay, so this point is 2 2. So solution for the system of linear equation is a point where the line intersect. Okay, when you graph, you get a two graph. Okay, when you graph a two equation, you get a two graph. Okay, and the solution for the system of linear equation means solution, that coordinate is a point where the two lines intersect each other. Okay, that is a common point. Okay, so here this is the only common point. Okay, so this is the point which is common for this line as well as this line. Okay, and that's what we are trying to find. We are trying to find a common point. Okay, we are trying to find a point which is common for both of the line. Okay, that gives us the intersecting point. Okay, now let's go back to our real example here. Let me erase this one. So in the elimination method, we eliminate one variables. Okay, it does not matter what variables to eliminate by adding or subtracting the equations. Now let's take our example 1 here. Okay, so we have this linear equation. Negative 3x plus 2y equals to negative 5 and 5x plus 4y equals to 12. Okay, let me rewrite this here. So we have negative 3x plus 2y equals to negative 5 and we have 5x plus 4y equals to 12. Okay, now if we add these two equations, can we eliminate one variable? Is there any variable that we can eliminate if we add? What happens if we add? Now let's see. So negative 3x plus 5x, that is a 2x, right? And 2y plus 4y, that is a 6y. So we still have a two variable, but we have to eliminate x or y. So it's not possible. Now, what do we need to have? Like how can we cancel two number? What do we need to have to cancel two expression? Okay, you are on the right. Yes.
Like you would have to multiply something to get
So in order to cancel, we have to have a same term with the opposite sign, right? So if we have a, let's say, so if we have 5x and positive 5x, we can cancel these two, right? Similarly, if we have 1/2 y negative 1/2 y, these two cancel, right? So every time if we want to cancel, let's see what we want. We need to have a same coefficient with the opposite sign. Okay, so here we have a negative 5 as a coefficient. Here we have a positive 5 as a coefficient. So we try to make a same coefficient. We try to make a same coefficient with our opposite sign so that we can cancel by adding. Okay, now here if we compare the coefficient here. Now if we compare the coefficient of x is negative 3. We have positive 5. That's not what we want. We want a same coefficient with opposite sign. Okay, y has a coefficient 2 and this y has a coefficient 4. That's not what we want. Now we can make the same coefficient with opposite sign by multiplying, okay, or by dividing. You can divide or you can multiply. Okay, now how can we make a same coefficient with the opposite sign here? So what variable do you want to eliminate at first? Do you want to eliminate x or y in this case? Choose one. Okay, y. Okay, so if you want to eliminate y, then what we need to have? So you need to have a same coefficient with the opposite sign. But right now our coefficient is 4 and 2. Now what do we need to multiply? Which equation do we need to multiply here? So so this is our first equation. This is our second equation. How can we make the coefficient of y same with opposite sign?
So
Multiply negative 2.
equation 1 negative 2.
Okay. If what happens if we multiply equation 1 by negative 2? Let's see. So if you multiply equation 1 by negative 2, and make sure you have to multiply both sides, okay? So you have to multiply both sides by negative 2. Now if you multiply equation 1 by negative 2, So we have negative 2 times negative 3x, that is positive 6x. Okay, so we have positive 6x. Make sure you multiply each term. Negative 2y, so negative 2 times positive 2y, that is negative 4y, equals to negative 2 times negative 5, that is 10. This is our equation 1. And our equation 2 is 5x plus 4y equals to 12. So this is what we had when we multiply our equation 1 by negative 2. Now, can we cancel one variable if we add these two equations? So what variable we can cancel? See, the y has a coefficient negative 4 and this y has a coefficient positive 4. It means this 2 is cancelled when we add these two. So if we are using elimination, your first target is making the coefficient of one variable same with opposite sign. Okay, now let's add these two equations. Okay, so we're gonna add, so 6x plus 5x, so we have 11x. Okay, negative 4y, positive 4y, it cancel, it is 0, so it is eliminated, equals 10 plus 12, that's 22. Now we divide both sides by 11. We are solving this equation for x. So we have x on the left side equals 22 divided by 11, that's 2. So our x is equals to 2. Now the next, we need to find what is y. So in order to find y, you substitute this x equals to 2 in any one equation. You can choose equation 1, you can choose equation 2. It does not matter, okay? Now let's substitute this equation. Let's substitute x equals to 2 in equation 1 or equation 2. It doesn't matter. Okay, so let me choose equation 1. So that is 3x. Okay, that is, so here, equation 1 is negative 3x plus 2y. So we have negative 3x plus 2y equals to negative 5. Now we substitute x equals to 2. So we have negative 3 as it is times x is 2 plus 2y equals to negative 5. We solve this equation. Negative 3 times 2, negative 6 plus 2y equals to negative 5. Now we get rid of negative 6 from left. So we add 6 on both sides. Okay. So negative 6, positive 6 cancel. So we have 2y equals to negative 5 plus 6, that is plus 1. We get rid of 2. For that we divide by 2 on both sides. And we have our y equals 1/2. And you write down x and y together in a order pair. So your x is 2, y is 1/2 inside the parenthesis, and this is the solution for this system of linear equation. It means when we draw a graph for each of these linear equation, we get the common point 2, 1/2. Okay, these two lines intersect at this point 2, 1/2. So this is the intersecting point for these two lines. So this is the elimination method. So you eliminate one variable. It doesn't matter what variable you eliminate. Okay. Okay. Do you have any question on this one? Okay. Now let's do the next example. Okay. I might need to erase here. So okay. So for number B, we have negative 2x plus y equals to 4. This is, let's call this is equation 1. Okay, and we have 4x minus 2y equals to minus 8. Let's call this is equation 2. Now we eliminate one variable. Now let's check the coefficient here before we eliminate. So the coefficient of x is negative 2. The coefficient of x is negative 6. We can't cancel by adding, right? These two are different coefficient. We want the same coefficient with opposite sign. The coefficient of y is 1. The coefficient of, this is number C. I'm sorry. So we are doing number B, right? The coefficient of x is negative 2. Coefficient of x is 4. These two are not same. The coefficient of y is 1. The coefficient of y is negative 2. We don't have a same coefficient with opposite sign. Now we have to make it. If we don't have, we have to make it. Now how can we make the coefficient of one variable same with opposite sign. You can multiply or you can divide the equation. That's the option that we have. So what variable do you want to eliminate, x or y? X, okay. Now if you want to eliminate x variable, let's see the coefficient. The coefficient is -2 and the coefficient is 4. Now how can we make the coefficient same here? What do we have to do? Okay. You wanna
Multiply times 2.
okay, multiply which equation? 1 or 2?
1,
Okay, by
2.
2. Okay, so if we multiply equation 1 by 2, let's see what happens. So we multiply equation 1 by 2 and make sure you multiply every term, okay, not only on the left side. You have to multiply every terms by 2. So you are multiplying the equation 1 by 2. So you multiply every term of the equation. So 2 times 2x and 2 times -2x and 2 times y. Make sure you multiply every term. So 2 times -2x, that is -4x. 2 times positive y, that is positive 2y, equals to, on the right side, 4 times 2, that is 8. And we have our equation 2, 4x -2y equals to -8. Now let's add these two equations.
Everything just cancels out.
Okay, now let's see. That's true. Okay, now here -4x plus 4x, that's 0, right? Positive 2y, -2y, that is 0. So we have 0 on the left and 8. Okay, we have 0 equals to 0. Now what does it mean here?
You don't intersect. That means it's in the origin.
No. So we have we don't here x is not equals to 0, y is not equals to 0. So if x equals to 0 and y equal to 0, then origin is the answer. But here 0 is equals to 0. That is true, right? Now let's see what this means by graphing. Now let's graph this equation here, okay? There's something interesting here. Now let's graph these two equations and we'll see from the graph. Okay, this is our x-axis, this is our y-axis. Okay, so we have origin here. Now let's graph this first equation. What do we need to graph a linear equation? We need at least 2 points, right? Let's find the x-intercept and a y-intercept for this first equation. So let's find the x-intercept for this one. How do we find the x-intercept? What do we have to do? We substitute 0 for y. So if y is 0 for this first equation, what is x? Can you do this on your head? So we are trying to find the x-intercept, right? So x-intercept means our y is 0, okay? So if this y is 0, what is x equals to? So we have -2x equals to 4. We divide both sides by -2. We get x equals to -2. So -2, 0 is the x-intercept. So our -2, 0 is somewhere here, okay? So this is -2, 0. Now let's find the y-intercept for the same equation. And to find the y-intercept, what do we do? How do we find the y-intercept?
0 for x.
Y-intercept are the point on the y-axis. Every point on the y-axis has x coordinate 0. So you substitute x equals to 0. So if x is equals to 0, this is 0. And what do we get for y? 4, right? So 0, 4 is the y-intercept. So we have 0, 4 over here. Now if you connect these 2 points, we get a line. So this is a graph for the first equation. Now let's draw a graph for the second one. So you can use the same x-intercept and a y-intercept concept, is easier. Now for the second equation, let's find the x-intercept. And to find the x-intercept, you substitute 0 for y. So this is 0. So if y is 0, what do we get for x? So we are solving this one, okay? So we have our y. So this y is 0, okay? So if y is 0, then our x is, so we have 4x equals to -8. You divide both sides by 4 and you get x equals to -2. So -2, 0 is the x-intercept. So we have the x-intercept here. Now let's find the y-intercept. And to find the y-intercept, we substitute x equals to 0. So you substitute this x equals to 0. So we have negative 2y equals to negative 8. You divide both sides by negative 2 and we get y equals to 4. So 0, 4 is the y-intercept. So we have 0, 4, the same point. If we connect, we get a straight line. Now what did you see here? So we have a line and we have the another line over it. Now it means we are looking for, so finding the solution means we are looking for the point where the line intersect. Now at how many points the line intersect here? Or do they intersect or not? So now here our first line, okay, so let me draw first line. So this is first line, okay, and second line is over this one. So we have the two line intersecting like completely from like starting to end, right? So that's right. So we have infinite number of solutions. So if you have a line intersecting intersecting completely the other line, then we have the one line over the other line. It means they intersect at an infinite point. And it's not possible to list all solutions. So we just write down infinite number of solutions. Okay. So this equation, this system of equation has infinite solution here. Okay. Your answer is infinite solution. Okay. It means we have infinite number of points where the lines intersect. Okay. So if you have something like true statement, so when you solve, if you get something like 0 equals to 0, or like 5 equals to 5, then you have the infinite solution here. Okay, so this is true here, so it means we get the infinite solutions. Now will there be a case where we don't get any solution? At what condition? Is there a condition where two lines do not intersect? They has to be parallel, right? So if we have two lines parallel to each other, then they do not intersect. It means it does not have any solution. Okay, if they intersect, then only we get the solution. Okay, now let's see what we have in number C. Number C must be the case where these two are parallel. Let's hope that. Okay, so let me erase here let me erase the part A here, and let's solve our equation C. Okay, so in number C, so this is for number C. So we have the equation negative 2x plus y equals to 4, negative 6x plus 3y equals to, okay, it should be 10, right? Is it negative 10 or positive 10? Okay, positive 10, okay. So this is equation 1, this is equation 2. Now the process is same. We try to eliminate one variable. Now which variable do you want to eliminate, x or y? The coefficient are not same. We have to make the same coefficient here, okay? The coefficient of x is negative 2, the coefficient of x is negative 6. These two are not same and opposite. Y has a 1 and positive 3. They are not same and opposite. So we have to make the same coefficient with opposite sign. Now let's eliminate variable x, okay? And for that we multiply by negative 3. Now let's multiply our equation 1 by negative 3. And make sure you multiply every term. So negative 3 times negative 2x, that is positive 6x. Negative 3 times positive y, negative 3y equals negative 3 times positive 4, negative 12. And our second equation is negative 6x plus 3y equals to 10. So we add these two equations, 6x minus 6x, that is 0, cancel. Negative 3y plus 3y, that is 0. So we have 0 on the left side. And negative 12 plus 10, that is negative 2. And we have 0 equals to negative 2. Is it true? It's false. Okay. Now, if we graph this, we're gonna get the parallel lines. Okay. It means it does not have any solution. So no solution. So we have the three cases. You might get a one solution, you might get an infinite number of solution, or you may get no solution. Okay, these are the three cases that we have for this system of linear equation. And if you plot a graph for these two equations, your line has to be parallel. Okay, what is the other way to check the lines are parallel or not? We check their slope, and if we get the same slope, then they are parallel, right? So let's see what is the slope here. So we have to rewrite for the y. So this it has a slope positive 2, and yeah, we get the 2 and 2 as a slope here. We get the same slope. Okay. Okay. Now here, so as we had in our example ABC, so we have the three cases. So if the two lines intersect at a point, okay, then we get one solution. Okay, that means the system is independent system. So we call that system where you get exactly one solution. That is an independent system. Your x and y, it does not depend to each other. Okay, we might get a system of equation which does not have any solution. It means when you have two lines parallel, they do not intersect. It means we don't have any solution, and those systems are the inconsistent system. Okay, and the third case is we might have a equation having a same graph, right? So we might get an infinite number of solution. So if we have the infinite number of solution, then we have that system is the dependent system. It means x and y variables, they are dependent. Okay, if it's exactly one solution, we get the one intersecting point. Okay, if no solution, two lines are parallel to each other. If infinitely many solutions, then we have the one line overlapping the other one. Okay, so these are the three different cases for the system of linear equation. And every time when you write down the solution, your solution has to be in an order pair. Okay, you write down x value, which is the x coordinate, you write down y together inside the parenthesis separated by the comma. That is the solution for the system of linear equation. Okay, do you want more examples for the linear equation, or we can go to the next one? Okay, so the next here we have the linear inequality. So we had earlier linear equation. Okay, now we're gonna have the inequality. So inequality means we see this less than equals to, we might see less than, greater than equals to, greater than sign. Okay, instead of equals to, we're gonna have less than, equals to, less than, or greater than equals to, or greater than sign. Okay, instead of equals to. These are the linear inequality, and our x and y variable, they are still linear. Okay, their exponent is still 1. The only difference is that instead of equals to, we have this inequality symbol. Okay, the inequality symbol, less than, greater than, less than equals to, greater than equals to, or not equals to. These are the inequality. Okay, if you see these inequality symbols, then those are the inequality. Okay, now here so we use the graphical method. Okay, so for the linear equation we had the elimination method. You can still use a graphical method. Okay, and in order to solve the system of linear inequality, we use a graphical method, and it's the same thing. Solving means we are trying to find the common solution for the system of linear inequality. So here we have this inequality, x plus 3y less than equals to 6. This is one inequality. We have negative x plus y greater than equals to negative 2. So we have two inequality. And if we have two or more than two inequality, that is a system of inequality. Now we try to solve or graph this system of linear inequality. Okay, now let's take one by one. So let me take the first inequality. So we take the first inequality, x plus 3y less than equals to 6. So we are trying to solve this system of linear inequality. Okay, we are trying to graph. From the graph we're gonna get the solution. The very first step when you are solving the system of linear inequality, the very first step is we replace our inequality sign by equals to sign. So we have this inequality sign, okay? Now we replace this inequality sign by equals to sign. So we have x as it is, 3y, positive 3y as it is. Instead of less than equals to, we have equals to 6. So every time if you are solving system of linear inequality, first step is you are replacing inequality sign by equals to, okay? So you replace inequality sign, that's the first step, okay, by equals to. Okay, this is the easy one. Now once we have the equation, once we replace, now what is this? Is this still a linear inequality? What is this x plus 3y equals to 6? Is this still a linear inequality? Do we have an inequality sign here? We have a equals to, it means this is a linear equation. Now we have the linear equation. Now we graph this linear equation, okay? Let's graph this linear equation. In order to graph, we need a y-axis, we need a x-axis. So this is x-axis, this is y-axis, okay? So we have origin. Now let's graph this linear equation. We need at least 2 points, okay? So you can just make a table. So we have x, y, and we have x, y. So let's find out the two solution for this equation. Now you can choose any value for x. What number do you want to choose for x? You choose one value for one variable and you find the other one. You want to choose 1 for x? Okay. So if x is 1, you can always choose any number, okay? But I would always recommend you to choose the 0. That's the easiest way. But you can choose 1. So let's go for 1. So if your x is 1, so if this x is 1, what is y equals to? Can you do that on your head? So if x is 1, what would be y equals to? So we have 1 plus 3y equals to 6. We get rid of 1 by subtracting 1 on both sides. So we have 3y equals to 5. We get a fraction, right? And we don't want a fraction. Okay, we hate, I know, right? We all hate fraction. So let's not get a fraction. So because it's not easy to plot a fraction on a graph. So it takes time. So it's like, okay, so let's try not to have a fraction. But you can have a fraction. But I'm going to use different number. 0. Let's choose the 0. It's the easiest way. That makes us very easy. So let's choose 0 for x. So if x is 0, if this x is 0, if x is 0, what is y equals to? So we have 3y equals to 6. So you divide both sides by 3. We get y equals to 2. So our y is 2. So 0, 2 is 1 point. Okay. Now now you choose y equals to 0 and find x. Okay. So if y is 0 now, so if you choose y equals to 0, then 3y is 0, right? And we have x plus 0 equals to 6. Our x is 6. So when you choose y equals to 0, your x is 6. So we have 6, 0 as the second point. So like here we are finding the x-intercept and the y-intercept. So when you graph a linear equation, use the concept of x-intercept and y-intercept. That is the easy way, okay? Now let's plot these 2 points. So we have 0, 2. So we have 0, 2. Okay, so 0 and 2. Let's say this is 0, 2. And we have 6, 0. So we have here 6, 0. So this is 0, 2. We have 6, 0. Okay? Now, once you have the 2 points, do not connect. Before you connect these 2 points, we have to check what kind of inequality do we have. Now, if we go back, in our inequality, do we have equals to sign? So our inequality is, so here our inequality is less than or equals to, right? So we have equals to. Now here is the hint. So if we have, so if you have less than equals to, greater than equals to, you're gonna use solid line to connect the 2 points. Okay? If you have strictly less than, if you have strictly greater than, then you're gonna use the broken line. to connect the 2 points. Two condition: if you have equals to, then you can use a solid line to connect the points to graph. If you have strictly less than or strictly greater than, then you can use the broken line. Okay, now in our case, do we use a solid line or a broken line? Solid. And the reason is, here we have x plus 3y less than or equals to, so we connect these 2 points by a solid line. So we connect these 2 points by a solid line. Now what does it mean by why we are having a 2 different line, like solid for the equals to and broken for strictly less than? What does it mean to us? Any guesses?
Whether the points on those lines are included in the inequality or not included.
That's right. So it means when you are using a solid line, means every point on the solid line are also the solution for this inequality. So we use a solid line here. It means every point on this line. So every point on this line are the solution for this inequality. Okay, so if we are using solid line, means every point on the line are the solution for our first inequality. If you use broken line, it means the point on the line are not the solution. Okay, now let's do the same. Okay, this is our next step. Now we have one more. Now this line, okay, solid line, divide our coordinate system into 2 parts. Okay, so we have like below this line and above this line. Now which one is the solution? That's what we need to find. And for that, we choose any point on this coordinate system other than point on the line. Can you choose one point for me which is not on the line? Any point. We have like infinite point. Now can you choose one point which is not on the line?
0, 0.
Okay, 0, 0. So we have 0, 0 which is not on the line. So we have these points. Okay, now let's choose this point 0, 0. Now we check whether 0, 0 is a solution for this inequality or not. So we choose, okay, so you can choose any point. Okay, choose 0, 0. Now we check whether 0, 0 is a solution for this first inequality or not. So our inequality is x plus 3y less than equals to 6. Now how do we check whether 0, 0 is a solution for this inequality? That's right. You substitute x equals to 0. You substitute y equals to 0. So we have 0 for x plus 3 times 0 less than equals to 6. So we have 0 plus 0. That's a 0 is less than 6. Now is it true or false? Is 0 less than 6? It's true, right? It's true. So here 0 can't be equals to 6. So I eliminated equals to here. Okay. 0 is less than 6. That's true. Now if it's true, means we have a point here. So we choose this testing point. And this testing point is solution for this inequality. It means every point which is below this line. So we have 0, 0 below this line. So every point below this line are the solution for this inequality. So whatever point we have below this line are the solution for our first inequality. Okay. So here we can, okay, so every point below this line are the solution for this inequality. Now we repeat the same process for our next inequality. Okay. Now let's take our second inequality. So we have negative x plus y. So we have negative x plus y greater than equals to negative 2. Okay. First step, you replace your inequality by equals to sign. So you have negative x plus y equals to negative 2. Then you plot a graph for this equation. So you choose x, you find y, and you get a xy point. Okay. And you always go for 0. That makes us easy until you get, if you get the fraction, you can choose something different. But if you don't get a fraction, 0 is the best option. So if x is 0, what is y equals to? Negative 2, right? So we have 0, negative 2. Now let's choose y equals to 0. If y is 0, then we get x equals to positive 2. So 2, 0 is the point. Now we plot a graph for this line. So we have 2, negative 2. So here So we have 2, so we have 0, negative 2. Okay, 0, negative 2 is here. Okay, 0, negative 2. And the next point is 2, 0. So we have 2, 0 here. 2, 0. Now, before connecting these 2 points, we have to check what inequality do we have. Our inequality is less than, so our inequality is greater than or equals to. We have a equals to. So see, if you have less than equals to, greater than equals to, you're going to use solid line. Okay. If it's strictly less than, strictly greater than, you're going to use the dotted line. Okay. Now, since we have the equals to, we're going to connect these 2 points using a solid line. So let's connect these 2 points using a solid line. Now this line also divides Cartesian coordinate system into 2 parts. We choose a point which is not on the line. Now what point do you want to choose here? Can we choose 0, 0? Yes, right? You can choose any point which is not on the line. Okay. So let's choose 0, 0 and check whether this is a solution or not. So here, so we choose 0, 0. You can choose any point, okay? It's not that you have to always choose 0, 0. You can choose any point. So our inequality is negative x plus y greater than equals to negative 2. So we have 0 for x plus 0 greater than equals to negative 2. So this is 0 greater than negative 2. Is it true or false? Is 0 greater than negative 2? Is true, right? So it means that every point which is towards this testing point, so whatever points we have towards our testing point is the solution for this second inequality. If it's false, you go away from the testing point. If it's true, you are pointing towards the testing point. Okay, we choose 0, 0 as a testing point here. Okay, so we choose 0, 0 as our testing point. If you get is true, you are pointing towards the testing point. If it's false, you are pointing away. Now, the last thing here, once you have this, you are looking for the common solution. Now, what part of the solution is common for both of this inequality? Now, for this green one, for this green first inequality, these are the solutions. Okay, right? Every point below this green line are the solution. Okay, so every point below this line are the solution for the first inequality. Now for the second inequality, every point above this line are the solution. Okay, every point above this line are the solution. Now, do you find a common solution here, which is the solution for both of these inequality? So dark blue part is the solution here. So here, you see this part here. This part is the solution for this inequality. Okay, you have to try to use a different color. It makes it easier. Okay. So this is how we can solve the system of linear inequality. We'll do some examples in our next class as well. Okay. So let's do this much for today. And if you have any question, I'll be here.